Hello everybody, my name is Chris Brady, author of the Boeing 737 Tech Guide and the Boeing 737 Tech Site. And this presentation is about the Boeing 737 Short Field Performance option. So in this one I'll be covering an overview, then looking at the various features, so spoiler deflection, high lift devices, the two-position tailskid, idle thrust delay, tweaks to the landing gear, software options required, and the various options surrounding the SFP package. As always, please treat your company training and their manuals as the authoritative source of information. Okay, starting with the overview. The SFP improvement package, as Boeing refer to it, it was developed in 2005/6 to allow GOL Airlines of Brazil to operate their 737-800s into the quite short Santos Dumont Airport. The runway there is 1465 meters or 4,800 feet, which is quite tight in an 800, and they were finding that they were payload limited. So they approached Boeing, and Boeing got to work. The first SFP was delivered to GOL at the end of June 2006, and the photograph there, taken by a friend of mine, Brian Lockett, who managed to catch this one, the prototype in development. And you can see the two-position tailskid there is deployed for landing. It's also got a static cone up at the top of the fin there, for static air pressure measurements, which are outside of the influence of the aircraft, and also a similar measuring on that second window back from door one left. So various extra sensors and things that are used on the aircraft during prototype testing. So what does the SFP give us? It either a weight increase for takeoff and landing from short runways, or to allow an aircraft of the same weight to use a shorter runway. It amounts to the same thing. You know, it's which do you want to optimize. Some approximate figures here from Boeing's own literature. The takeoff field length limited takeoff weight is increased by 1,500 pounds. Climb gradient limited takeoff weight by an impressive 4,000 pounds. The takeoff roll is also reduced by 70 meters. And for landing, the VREF is reduced by 7 to 8 knots, does depend, at flap 30, and around about 4 knots at flap 40. So there's quite a big advantage at the flap 30 stage there. Which is unfortunate, because obviously for short fields you would tend to use flap 40, but there we go. The field length limited landing weight increased by a very impressive 7,800 pounds, and the landing roll reduced by 100 meters. So there's a whole lot of performance improvements in there. To sharp pencil this, what I've done here is I've shown you an extract from the flight planning performance manual. The page I'm displaying here is for the SFP. This is the SFP1, so it doesn't have the two-position tailskid, but it's got all of the other features. And I've compared that to the same 737-800 winglets without SFP, which I haven't shown on this page because it would be too busy, but you can see from the area I've circled and the enlargement of that, that you're getting around about a 2-ton weight weight benefit for these circumstances here. So just to outline what these circumstances were. So it was the 7B26K engine, standard category CM brakes, and this is the takeoff field limit dry runway, flat 25 packs on, anti-ice off. and they're both using a fill length of 2750 meters available, 1% upslope, 20 knots headwind component, OAT of 32, and a pressure outlet of 4,000 feet. And again, if you crunch the numbers, and you can see the reference line going up and across, and sliding here, there, and everywhere, you pop out with 74.6 with the SFP as opposed to 72.6 with the basic 800. So 2 tons is really quite significant. That's what, 20 passengers in round numbers. So it does make a difference to the flight being arguably profitable or not. Okay, so let's take a look at the features in turn. I'll start here with the spoiler deflection. So this is what occurs on landing. So it's only landing, not in flight. And you can see that the top photo is showing the flight spoilers on the SFP aircraft a full deflection after touchdown. The bottom photo is actually showing where the spoilers retract back to after 60 knots, and that's the same position that you see in a regular 737, the regular non-SFP 737. So bog standard, I don't know, 8 or whatever series you like. If it's not SFP, you can see the ground spoilers are unchanged at 60-degree deflection. But when the flight spoilers deploy on the ground, they've been used as ground spoilers as well, you get an increased deflection on the inboard pair of 65 degrees from 38, and the outboard pair of 56 degrees from 33. And that does two things. Obviously, you've got an increase in form drag, which slows the aircraft down faster. But secondly, and probably more significantly, it actually helps dump that lift and decreases the loading on the main landing gear, which improves the braking effectiveness. As I've already mentioned, these return back to the normal range at 60 knots, and the in-flight deflections are unchanged. So the in flight, it's as per the bottom picture as max. Well, obviously for the flight spoilers only, ground spoilers don't deploy in flight. So that's the big difference, is this ground deflection of flight spoilers. Actually, I think I did I say a moment ago that this was for landing only? Obviously, it's also applicable in the RTO case as well. So that also improves field length limit for the RTO case for takeoff. Okay, high lift devices. Now, those of you who flew the classics will know that the approved takeoff flap configurations were 1, 5 and 15, and those who flew the originals will know that you could also take off with 2 as well. Now when the NG was introduced, flap 25 was added as an approved takeoff configuration, but there were actually no changes to the flap slat sequencing until the SFP. So this is the difference. If you look at the graphic on the right hand side, because that kind of says it all, the right hand column is the position of the slats on an SFP. The column just inset from the right is on a regular non-SFP 737, and you can see the difference is in the flap 10 to 25 range. That's when the slats will be at full extend on a regular 7.3, but only at extend on the SFP. This I know, maybe counterintuitive to some. You think, well, surely you get more lift at the full extend position. You do, but you also get more drag. And it's the lift to drag ratio which is significant, which is what counts. So what this means is that for all takeoffs with the SFPs are done with the slats in this what we call sealed position, just at extend. Sealing those slats when the flaps are in takeoff positions, it reduces drag and allows the wings to generate more lift at lower rotation angles, thereby reducing the takeoff speeds. So that's the crux to it. So it reduces the takeoff speeds is what this does. Reducing the speeds, reduces the field length, and or increases your payload. I didn't unfortunately have a compare and contrast photo of a regular 737 and an SFP at either anywhere between 10, 15 or 25. This is a photo of a well, actually it's a max, but it doesn't matter. All the 737s ever built at landing flap 30 or 40 have got this gap between the slat and the leading edge, and yeah, I just include this photo because you can actually see it quite well in this photo at that angle. Now, during the development of the SFP, Boeing actually experimented with having the Kruger flap seal door open at flap 40. And you remember I spoke about this in the flaps and slats video presentation. That this door kind of hinges to allow movement of the translating sleeve for when thrust reverse is deployed. So Boeing thought, well, can we make that open? Other than when reverse is deployed, in flight, will that give any benefit? And they tried it in the wind tunnel, and the wind tunnel said yes. So they thought, right, great, we'll build this in, try it in flight. But unfortunately, flight testing didn't give as good results as the wind tunnel modelling had led them to believe. So the idea was dropped. So that's actually not a thing on the the SFP or the regulars. It was dropped, which is what flight testing is all about. To find out if these things will work or not. Wind tunnels don't have all the answers. Another difference is in the power transfer unit. The logic for that has been adjusted for the SFP slat sequencing. Now, as a reminder, the PTU is what it does is it operates automatically to operate the leading edge devices for either normal or autoslat operation if the B system engine driven pump pressure, that's the high output hydraulic pump, is lost, and you're airborne with flaps 1 to 10 on a regular aircraft. Well, obviously that's not going to cut the mustard for the SFP, where climb performance is and indeed field performance is an issue. So this will kick in at any time with the flaps not up on SFP aircraft. So that's again just a tweak to the logic, and there are several of these with the SFP because of this change to the slat sequencing. This is one. The autoslats is another. So the autoslats, which again just to remind you, these will automatically move from extend to full extend if a stall is approached. So if you're in just a flap configuration, well, more specifically a slat configuration, where the slats are only at extend, it will pop these out to full extend for you as you approach the stall. On a regular aircraft, it's obviously only when the flaps are 1 to 5, because that's when they're only at extend. On the SFPs, that range is increased from flaps 1 to 25, because again that's when the flaps are only at extend. So it'll, at any time the flaps are extend, it will pop them out to full extend for you if a stall is approached. The leading edge flap transit light logic again has been adjusted for the SFP. That's the list of criteria, and you can find it in the FCOMs. I'm not going to read it all out to you here, and insult your intelligence. But the highlight is that bit there down at the bottom in red. So during alternate flap extension, This will go amber until the leading edge devices are fully extended and the trailing edge flaps reach flap 15 as opposed to 10 on a normal aircraft. The leading edge flaps extend light, the green light down at the bottom right, again a tweak for logic for the slaps. This is when trailing edge flap positions are now increased out to 25 as opposed to just 1 to 5 on a normal aircraft, and again when the leading edge devices are fully extended. So again, trailing edge flap positions 30 and 40. And the last one of the trio is the flap load relief light. And this function, the flap load relief function, is armed on the SFPs from flaps 10 or greater. So this is actually quite a significant change, and a more useful rather than a trivial thing to know, as were the other two lights perhaps. So you have flap load relief from flap 10 or greater. This is a big change from a regular aircraft, and it is actually nothing to do with the slat sequencing. This is a kind of new design feature. A thing to point out is that although the flap load relief range is now increased all the way down to 10, the flap load relief will only retract the flap by one stage from whatever flap lever position you're at. So if you really go bust in your VFEs and you're expecting it to flap load relief all the way back to, say, I don't know, 15 from 40, it won't do that. It will only go one stage. So it'll retract the flaps from 40 to 30, or from 30 to 25, or from 25 to 15, or from 25 to 10. But it won't do multiple stages for you. Just a reminder, flap load relief is not available with alternate flap extensions. So if you use the electric system to extend it, that's it. It stays where it is. And the final thing to mention is that the flap load relief light is optional. The function is fitted to all aircraft, and the extended function is fitted to all SFPs, but the light is optional. So don't think because you haven't got the light, you haven't got the function. You do. It's there. This is the graph showing the activation and reset cycle for each flap setting on the MAX SFP, but it's the same for the other SFP models, the 900ER, the 800, what have you. But this was the best graphic I had. And you can see the activation cycle. So as you accelerate up to 176 at VFE plus 1, the flaps will retract a stage. As the aircraft decelerates back to VFE minus 4, the flaps will extend back to 30. And that cycle, you can see, that can happen all the way down from 10 to 5. Right, one of the big features of the SFP was this two-position tail skid. So let's have a look at that. The photos there are showing it in the retracted position, and quite a tricky photo to get is the tail skid extended. Now the basic tail skid, so the basic non-SFP tail skid, the one we saw on the 400 and most of the 800s. And the 900 actually, protect the fuselage from tail strike damage from over-rotation during takeoffs. Okay, they don't actually protect the aircraft during landing. Now the SFP two-position tail skid aims to address that. So this is an optional feature. Not all SFP aircraft have got this, and if you've got it, the tail skid will extend an extra 12.5 or 5 inches for landing protection. This allows greater angle of attacks to be safely flown, thereby reducing the permissible VREFs, and permissible and programmable in the FMC, and hence the landing distance. So if you can reduce the VREF, obviously you can get the landing distances down. The tail skid will automatically extend for us when the gear is extended in flight. So when you drop the gear, the tail skid comes down. Important to note that the tail skid only extends for landing, not takeoff. It will retract again when the aircraft has been on the ground for more than 5 seconds, which is why it's a difficult photo to take. Or the landing gear lever is not down, in other words, you've gone around, or both engines are not running, which is either shut down if it hasn't shut down because of the 5-second timer after landing, or perhaps you've lost both engines in flight and you're gliding and it's a drag reduction feature. I'm sure both are equally useful. So, what protection does it give us? Well, this is the graph that you can find in the FCOMs, and it shows the body contact angle on the 1 position and 2 position tail skid there. So that basic ground contact pitch angle, it's actually reduced by 0.5 degree because of the 2 position tail skid. So you'd think that's actually not doing us any favours, because we're going to touch with the tail skid sooner. Well, kind of yes you are, but assuming you don't hit the tail skid, because the lower approach speeds can be safely flown, they are permissible, so you get the lower VREFs, and as I said earlier on, the VREF is actually reduced by 7 to 8 knots of flap 30 and 4 knots of flap 40 because of those lower approach speeds. So it's 2 things kind of almost against each other, but the beneficial one, the overriding factor here, is that reduction in VREF. The 2 position tail skid, it's optional for the both the 800 and the Max 8 and A200. It's standard though on the 900ER, the 9 and the 10. The option comes with a cost. It's $274,000 US in 2006 prices. That's the only figure I've seen. I don't know what it costs today. But probably a little bit more. It adds an extra £70 to the basic aircraft weight, which obviously has got to be factored in, but given those lower approach speeds and better landing performance, I'm sure it more than outweighs the benefits, more than outweigh that £70 weight penalty. Installation of this must be done during production. Retrofit of that 2 position tail skid is not possible. So it's a customer selectable option at order. Okay, a subtle difference here is in the Autoland tailwinds. Now, these 2 extracts I'm showing you here, these are from the AFM, the aircraft flight manual. So you don't actually normally see these in the FCOM. But I've got them here, and I'm displaying them for you, just basically for the sake of completeness and for background knowledge, perhaps, of the SFP. So what the top chart is table, sorry, is telling us is that the demonstrated Autoland tailwind for the 737-800 with the 2 position tail skid is reduced from 30 knots to 20 knots. Now, I'm sure everybody watching this is going to think we have no idea that the Autoland, the automatic landings have been demonstrated in 30 knots. Our limit only 15 knots. Well, yes, it is, and I'll come on to that well, I'll say it now as I mention it. Just for the avoidance of doubt, the figure in the top table is not your Autoland tailwind limit. This is it's a demonstrated VMC condition wind, and it's done to determine the Autoland performance of the aircraft. It is not something to be used operationally. It's it's all. How can I best describe it? It's a certification requirement to to demonstrate these things. So anyway, this hypothetical, if you like, 30 knot demonstrated figure is actually reduced to 20 for the 800. It doesn't matter. It doesn't affect our operational IMC tailwind figure that we use on the line of 15 knots. Why the figure was reduced, I don't actually know. I haven't seen an answer in black and white. I've approached a couple of people at Boeing and I haven't had an answer certainly yet. My suspicion is that with the lower approach speeds that the SFP has, the tailwinds are beyond the flare capability of the flight control computer for the 800. But I don't know that. That's just my theory. Anyway, it's more of an academic thing. As I say, for operational use of Autoland, see your FCOMs and your company limits for the tailwind limit. Just a little flashback to the PSEU video I did. For those of you who watched it, you might remember this. For those of you who haven't, give it a look. It's full of good info. But another way we can tell whether we've got the two-position tailskid is to look up the aft overhead panel, and if you're on NG, you will see an extra light up there, which is the SPSEU, the supplementary PSEU. The Max, you won't see a different because it's all wrapped up with the new Max version of the PSEU, and the light it's just a single light, and it's called maint for maintenance. Anyway, the two-position tailskid, I actually, as I do with the one-position tailskid, I cover them all in great detail with the tailskid video, which will be coming out in a week or two, and it also goes into the mechanics and more of the performance differences on the various tailskid options. Okay, next feature is an idle thrust delay. One of the more subtle ones, but the regular NGs, as you may be aware, that there's a 5-second delay after touchdown before approach idle, which is around about the 72-79% N2 mark, reduces to ground idle, which is about 60%. Now this delay is intentional, and it's there to reduce the spool up time, both either for maximum reverse thrust for when or if you ever need to use that, or for the bulk landing case when you might need to spool up and go around. So that's why the 5-second delay is there. Now with the SFP, well, with so the benefits are you've got that spool up time available to you for full reverse or the bulk landing. The drawback is that you've got what's known as a residual forward thrust. So if you think about it again, cast your minds back to the to the power plant video I did. When you select reverse thrust, the thrust that is reversed, if you like, the air that's deflected forward, is the bypass air. The core airflow actually still goes straight through the engine and and through the regular exhaust flow. So what you've got is you've got the residual thrust, if you like, is the difference between the fan air, which is pushed forward, and the core air, which goes backwards, and your reverse is the difference of the two. Now, if you've got more than or a higher idle thrust going through the core, that's going to propel you forward that little bit more, and that is going to eat into your landing roll. So, for the SFP, Boeing elected to reduce this idle thrust delay from 5 seconds to 2 seconds. So that reduces the period of the residual forward thrust from 5 to 2 seconds. That shortens the landing roll and will improve your field length limited landing weight. Alright, let's look at the landing gear changes. The first is extremely subtle, and if you look at these photos, I know because I've double and triple checked that I've got these photos the right way around. But to me, it still looks like the top photo, the landing gear is tilted in a little bit more than the bottom photo. But it must be an optical illusion. Anyway, whichever way around I've got the photos, it is a fact that for the SFP, what Boeing did was they brought in the landing gear strut, the main landing gear strut, by 1 degree. Now, I mean, that's why you can't see the difference. I mean, 1 degree is really very hard to see, and that the what that did is it reduced the camber, if you like, of the main landing gear, and this was probably best described by the guy that brought it in, Mike Delaney, the chief project engineer, and he said we brought it in by just over 1 degree, which increases the uniformity of braking across all 4 brakes, and will help tyre wear issues that we've seen across the fleet. It's a maintenance benefit. So this is it's got 2 uses. Tyre wear is one use, and that's why this was actually adopted and carried forward on all non-SFP aircraft after the date of introduction as well. But as far as the SFP goes, that uniformity of braking is the key phrase to hang on to here. Uniformity of braking means better braking effectiveness. And you can imagine if the tyre's wearing uneven, the braking's uneven, and the braking won't be at its maximum efficiency. So this subtle difference again was done to increase the braking efficiency, which reduces stopping distances. Talking of brakes, carbon brakes. This was actually, or they were introduced in 2008, so it was a couple of years after the introduction of the SFP. So, but I'm including it in the SFP presentation here because of the benefits of carbon brakes. Now, Boeing's line on carbon brakes is that stopping performance of carbon brakes has been shown to be equivalent to steel brakes. However, for some aircraft configs and flight conditions, carbon brakes show better stopping performance compared to steel brakes. They're also 300 kilos lighter, and if you're not carrying 300 kilos on your landing roll, you're going to stop that a little bit sooner as well. So there's a small difference there. They also last twice as long, so there's a decent cost benefit there. So again, like winglets, whilst they're not part of the SFP package, it may be advantageous to have this option selected. We can see it either in the FCOM there as Cat C/M brakes, or it should be in your tech log telling you, or your FCOMs, which brakes categories you've got fitted. But needless to say, carbon brakes will be useful either for weight or for stopping performance on SFP aircraft. Software updates. There are several software updates which are required for SFP aircraft. So the first note, the one that we will see as pilots, is in the IDEM page on the FMC. Now I will come back and mention this in a little bit more detail in a moment when I cover options, but also the model engine database. And this, if you're not familiar with it, this is a database that the FMC holds for all well, models are, the series, if you like, 5, 6, 7, 8, 900, or a 900 ER, or an 800, or an 800 with winglets, or an 800 with winglets and some SFP features, or an 800 with winglets and the two-position tailskid, which is an option in itself. So all of these different permutations of models and the different engines, because as we know we can operate the aircraft at many different thrust settings, all have to the FMC has to know which version you're operating, and that it used to form a new aerodynamic model of the aircraft. And this becomes apparent to us in things like the speed schedules, the optimum operating altitude. Again, we know, I covered it in the winglet video, that you can reach your optimum altitude, and you've got a better altitude capability with winglets than without. The FMC needs to know that. The buffer limit envelope, the engine out and QRH takeoff speed, stab trim data, all of these things the FMC needs to know, and it can only know it if it's told what version of the aircraft and what engines are operating. That's what the model engine database is all about. So for the SFP and the various options, it needs to know that. The updated model you'll see on the ident 1 page, and also the model engine database part number is on the ident 2 page. The model engine config also appears in the maintenance page of the FMC, which gives a bit more details with a thing called a config number, and this is unique to the combination of all of the other parameters shown on the page. So the type of SFP, winglet or not, engine type, SAC DAC engines, tech insertions, evolutions, engine ratings, and brakes. All of that gets rolled into this config number. The flight control computer also had to have a software update again, and I alluded to this when I was talking about the Autoland tailwind capability, which was reduced. So obviously things needed to be tweaked and improved on there. So the Collins flight control computer software, that particular part number, known as the 140 or the P4 software, was released in August 2006, and it was developed primarily to include the SFP options. And again, the autopilot needs to know how to fly the aircraft with the various modifications. So there's changes in both the application program and the bike programs associated with the SFP option. Another change was to the SMIDs, the stall management yaw damper computers. The Dash 7 SMID was developed for the SFP and became the standard SMID for all production 737s after line number 2011, which was released August 2006. So as I say, became the new sort of baseline SMID. Whether you've got SFP or not, it's just future-proofing. Now, why did the SMID need updating? It's because of those leading-edge slats in the extend position for those extra flap positions of 10, 15, and 25. The fact that you've obviously got different stalling speeds associated with that, and the order slat can gap those slats for those stall positions. The order slat needs to be told by the SMID to kick in and operate. The Dash 7 SMID's got also a unique trip schedule for the SFP stall warning, order slat, elevator field shift. Remember me talking about that in flight controls pitch, and stall identification functions. The updated SMIDs must also be installed to ensure that the CDS, the display system, receives correct information as to the model type. So be it 800 SFP, 900 ER, whatever it might be that the CDS is operating on. If you ever pop your head in the in eBay, you can actually see what version of SMID you've got. I've highlighted it in the photo on the right there. You see a little thing PNR, which is part number, or P/N for part number, and then there's a long number which you don't need to know, but at the end of it is a dash, and these photos, these are -6s. The only thing you need to know really is that the two SMIDs need to be the same. You can't mix and match, and that for an SFP it's got to be 7 or later. These are actually 6s in this photo, because it wasn't an SFP that I took these photos from. The CDS, which I mentioned with the SMIDs just before, the common display system, this has had many updates. So when you fly older aircraft and they don't have the same functionality as new ones on the displays, then these are the updates that Boeing released. So Block Point 6 issued September 2006. I think that should be August 2006 actually. Contains the operational program and the display unit database, and this has got updated coefficients for the SFP aircraft, and those are revised flap schedule speeds, the VREF plus 15 or 20 depending on your option, not white bug speed, angle of attack approach reference for the angle of attack option, and the stall speed angles of attack. So all those things which are displayed for us on the PFD, they all need to be told that they're applicable for the SFP aircraft. Again, as with the FMC, the SMID, and the FCC, these coefficients vary not only with the model, i.e. an 800 or 900 ER, but also with the particular options selected. So two-position tail skid with winglets, or with or without anti-collision light shield, again going back to the winglets video, or load alleviation system, or whatever it might be. These all affect the flying characteristics, if you like, of the aircraft, and hence what must be shown to us on the either speed tape or the alpha gauge. Okay, the last thing is to look at the various options. We've talked about what those options are, in detail before, but what I mean is options as fitted for the types of aircraft. So what options are available for what particular models? So looking at the short bodies first, the 6, 7 and the 600, 700 and the Max 7. Actually, first thing I should say is that none of these options are available for the classics. This is just for NGs and Max. So regarding the short bodies, Boeing did offer the ground spoiler and slat features of the SFP package for the short bodies. Obviously none of those models have got a tail skid, so that the two-position tail skid was never an option. That would be a complete waste of money. And the Max 7 actually is unique in the Max family, as it's the only version of the Max which has not been built with the SFP slat sequencing. All of the others, the 8, the 9, the 10, the 8200, they've all got the revised slat sequencing. It just came as standard. Now, I am not aware of any short body SFP aircraft in existence, and please, if you know of one, let me know about it. Ideally, send me a photo of the ident page, because I've flown many of them, and I certainly know people who've flown many of them, but I haven't yet come across anybody who's said that there is either a 600, a 700, or a 7 with an SFP option. So please let me know if you know of one. Now I think the reason is probably best explained by Gol's experience. This photo you see in set, that's actually me flying that aircraft on a post-maintenance test flight and customer demo flight. if you cast your mind back to the reason why SFP came about in the first place, it was for GOL's operations into the short Santos Dumont airport. Now, GOL actually, as you can see in the photo, they operate the regular 700. And they, talking to GOL pilots, they can actually lift a full payload on flights of up to around about an hour and 40 minutes. So they don't need the SFP option on their 700s, and the same is probably true for other operators. Unless you've got this curious combination of wanting to fly a short-bodied aircraft at full payload on a long distance, well, relatively long distance flight, you ain't going to need the SFP option. And frankly, I think if GOL didn't need it and they operate the 700, then nobody would need it. But again, as I say, if you know of one, please let me know. Show me a photo of the IDEM page. I'd be fascinated to see it. For the 800s and the MAX 8s, basically all options are available. I mean, with the 800, you've got 800 without winglets, 800 with winglets, 800 with the SFP options minus two-position tailskid, and 800 with winglets and SFP options and the two-position tailskid. So there's 4 different options for the 800 alone. And they are shown to us as either a .1 or a .2 suffix on the model on the IDEM page. It is possible to have an 800 with an SFP option, but without winglets. But again, it's another option I haven't seen. So if you know of or are flying an aircraft with an 800.1 or an 800.2 without winglets, then again, please let me have a copy of the IDEM page. I would find it fascinating. Now, the MAX 8 and 8200, they have all of the SFP features as standard, except for the two-position tailskid. They also have winglets as standard, so they've dropped the W suffix from the IDEM page. So what you will see in a MAX either 8 or 8200 is 8.1 or 8.2. I say the 8.1 is standard. That just basically means you've got the SFP, which comes as standard, and the one-position tailskid. The 8.2 means you've got the SFP and the two-position tailskid. So that's the decode, if you like, of the IDEM pages for the 800s and the 8s. With the 900s, 900 ERs, 9 and 10s, well, the 900 was built before the SFP was introduced, so they don't have any SFP features. Winglets and carbon brakes obviously can be retrofitted, so for a 900 on the IDEM page, you're only ever going to see 900. The 900 actually became the 900 ER in 2006 because of the SFP. So it's one of these things in the sort of development of the 737. If you think of the chronology, GOL put in the request for a short field version of the 800. Boeing got to work on it, came up with this suite of improvements. Then looked at the 900 and thought, well, if we put them on the 900, we could really make something of that aircraft. They did. They also put the mid-exit doors on it, and hey presto, there's your 900 ER. So the 900 ER, the IDEM page will only ever show up as 900 ERW. That is the only version of the 900 ER ident you will ever see. They don't specify .1 or .2 because they are standard. They're all .2s, if you like. I know there's a bit of a flaw in the logic in that they declare the W. whereas because the winglets are always standard on 900ER, I didn't say Boeing were consistent. I'm just trying to explain the logic as best I can. But there you go. With the Max 9 and the Max 10, I'm sure, but I don't have an ident page photo to show you. They don't show any SFP suffices or the wingless suffices either, because they're all standard. So if you see if you're in your Dash 9, your Max 9, that's all you will see, even though you've got the full SFP package and winglets. One last thing to mention is that some operators helpfully put a decal in the flight deck to notify or remind the crew the aircraft is either a partial or a full SFP. This I suggest is quite useful when operating a mixed fleet, although of course it should be also listed in the tech log or wherever else it is in your company documentation that your particular airframe is an SFP. But I quite like this touch. I'm a big fan of this decal. It's helpful to us, which if you're anything like me, you can use all the help you can get. So quite nice to have this. This particular photo is actually on a Max. Well, actually, it's an A200. Even though the slats and the spoilers are standard on this model, and this particular operator doesn't have the two-position tail skid, so the decal isn't actually telling you everything. You could be forgiven for thinking with this decal you might have had the optional two-position tail skid, but as I say, this particular operator doesn't have any with the two-position tail skid. So obviously, what they're meaning is it's just the other features, the other SFP features, and it's done, I guess, because they operate the 800s as well, some of which are short SFPs and some of which aren't. So there we go. Summarising all of those options. So going across the top, we got the short bodies, then the 800s, the Max 8s, 900, 900ER, and 10s. You can see which of those features were optional, which were standard, which were not an option at all, and a little tie up at the bottom of the FMC ident with those particular features. One last thing to say is retrofitting. Now, as far as I know, the various SFP options can only be installed during production, and no SFP features can be retrofitted. Now, in the very first SFP airplane configuration bulletin, and these are the documents that Boeing used to announce new features or design changes to operators. The very first one of these stated that currently Boeing is studying the possibility of offering the sealed leading edge slats for takeoff portion of this package for retrofit, and that provisions for these options will be provided on all aircraft. On a later update to that ACB, they changed this line to retrofit of the short field performance optional feature is not available, and I believe that was the final position by Boeing. So no retrofitting was available as far as I know. Again, if you know different, please let me know. Certainly I do know that the two-position tail skid was absolutely never on the cards as being a retrofit, but I thought it was possible, or certainly looking at this, it was possible that the gap slat was a possibility, or the increased flight spoiler deflection on the ground. But I believe, certainly from what I've read in the latest ACB, that idea was canned. So there you go, that's all about the SFP. If you've enjoyed this video, please as always give it a like, subscribe to my channel if you haven't done so already. Consider buying a copy of the book if you want all this information in either a hard copy format or on your iPads. The next video out will be tail skids, and I will cover the 1 and 2 position tail skids in a lot more detail in that presentation. As always, thanks very much for watching, and thanks for your continued support.